All right, hello, lovely Year 12 students. Today we're looking at the vector equation of a sphere. We previously looked at this in chapter 4 in 2D and for the vector equation of a circle, and we can basically apply the same logic to looking at a three-dimensional sphere. And so basically the vector equation of a sphere with center 0, 0, 0 with a radius of a is given by the equation, the absolute value of r is equal to a. And if we write it in, if we expand that in Cartesian form, we get the x squared plus y squared plus z squared is equal to a squared. And so that's our two forms for the equation of a sphere. However, if we offset the center, so it's not going through the origin, we include the take d there, and that would indicate its new center. And then there we've got the same thing as well in Cartesian form. So let's go ahead and look at some questions to do with this. So here we want to find the center, radius, and vector equation of a sphere with the Cartesian equation below. So let's go ahead and do this. So essentially what we want to do is we're going to put all the x terms together, all the y terms and z terms, and then complete the square. So let's go ahead and do this. So we're going to have x squared plus 2x plus y squared take 4y plus z squared take 10z, and I'll leave that 6 on this side over here. Now I'm going to complete the square for each one. That's going to be x plus 1 squared. That's going to generate a 1, so I'm going to take 1 away, plus y take 2 squared. That's going to generate a 4, so I'm going to take 4 away, plus z take 5 squared. That's going to generate a 25, so I'm going to take 25 off, is equal to 6. And so then I put all the loose terms, all the loose numbers on the other side. So I'm going to get x plus 1 squared plus y take 2 squared plus z take 5 squared. All right, 6 and 25 is 31, 32, 36. Cool, sweet. Alrighty, so that's our Cartesian equation of the equation of a circle. So it would have a center at what would the coordinate be? It would be at -1 to 5, and it would have a radius is equal to 6. So what would the equation be then in vector form? Well, it'll be r take -1 to 5 is equal to 6. So there's our vector equation of the sphere and our Cartesian previously there. Alrighty, second example here. So we want to find the position vector of the points where that particular line cuts through a sphere. So if we try and visualize it, what are the possibilities? So it's going to draw. Here's our sort of our sphere shape here. And if we have a line cutting through that, we're essentially going to have one point of entry, one point of exit. However, if the line is just touching the sphere at a tangent, there would just be 1. So we're either looking for 0, 1, or 2 points where the line cuts through the sphere, and they are different possibilities. So let's write out each of the things that we've got here. So our line, its position is equal to, okay, so 1, -1, 2, plus some lambda amount of 2, 9. Now there's no k, so that must mean it's equal to 0. And then for our sphere, our equation is going to be take 1, 2, -1. Cool. So we've got our two lines there. So we want to find where the line cuts it. So essentially, if we put in the line into the sphere equation, we can then figure out what lambda is going to be and then solve for the position vectors. Okay, so let's go ahead and do this. So what I'm going to do is I'm going to say, okay, so we've got the absolute value of, I'm going to write it as a single vector. So 1 plus 2 lambda, -1 plus 9 lambda, and then we just got 2, take 1, 2, -1 is equal to 7. Okay. Now we can go ahead and simplify that. So that's going to give us, all right, 1 take 1 is 0. So that's just going to be 2 lambda. That's going to be -3 plus 9 lambda, and 2, that's going to be a 3 there, equal to 7. So if we simplify that, so that's just going to, that's telling us that 2 lambda squared plus -3 9 lambda squared squared. So really it's the absolute value, so it's the square root of all of that, like that there, is equal to 7. But I don't like writing that square root there, so I'm just going to square both sides, and so that would just give us 49 over there. So that's nice and easy to work with. And then if we were to, we can simplify and solve. So, if you were to simplify all of that there, you would be left with 85 lambda squared, take 54 lambda, take 31 is equal to 0. So I've just gone ahead and pretended I've done that on my class pad. And then you'll get two positions here. So we're going to get lambda is equal to 1, and or lambda is equal to -31 over 85, like that there. So then what we would do then is we would substitute those particular values into the equation, and then that would help us determine the position point. So let's just hold on here a sec. So in this example here, so we would get, if we put those back in, so if lambda is equal to 1, we'd put that back up into there. So that would be 3, 8, and 2. So we would get, and then you probably need to use a class pad for the other one. So it'd be 23 on 85 minus 364 on 85 and 170 on 85 for that one there. Which should just be 2 for that one there. Anyway, cool. So that's what we're doing there. So basically just substitute it, the line into the sphere. We'll just write that. Here we So all it did is substitute the line into the sphere, then solve for lambda. Cool. Hope this helped.